Hello everyone, this is Haoyu Wang, and here's homework 10 from class EL6303 class. The first question is from the lecture notes, page 1 to 50, and we need to collect the definitions and the simple properties for each examples of each one. And the first one is the Poisson process. It is the number n t1, t2 of the points in Ti in the interval t1 to t2 of the length is t equal to t2 minus 1 is a Poisson random variable with parameters lambda t. The equation is p of n t1 t2 equal to k equal to e to the negative t times lambda t to the k over k. The first order of probability methods is p of xt equal to k equal to e to the negative lambda t times lambda t to the k over k. The mean is e of xt equal to lambda t, and the autocorrelation is r of t1 t2 equal to lambda squared t1 t2 plus lambda times the minimum of t1 and t2. The autocovariance is C of T1 T2 equal to lambda square of T1 T2 plus lambda times the minimum of T1 T2 minus T lambda times T1 times lambda times T2, which is equal to lambda square of T1 T2. So the answer is lambda times minimum of T1 T2. And the second one is Poisson increment, which is yt equal to x times e plus x of t plus e minus x of t over e, which x of t is a Poisson process. The first order of probability methods is p of yt equal to n over e equal to e to the negative lambda e times lambda e to the k over n. The main is e of yn equal to lambda, and the autocorrelation is r of t1 t2 equal to lambda square, while t1 minus t, the absolute value of t1 minus t2 larger or equal to e, and r of t1 t2 equal to x squared plus lambda over e minus lambda times the absolute value of t1 minus t2 over e squared, only when absolute value of t1 minus t2 smaller than e. And for the autocovariance is C of T1 T2 equal to 0, while T1 minus T2 the absolute value is larger or equal than E, and equal C of T1 T2 equal to lambda over E minus lambda times the absolute value of T1 minus T2 over E squared, only when T1 minus T2 of the absolute value smaller than E. For the point impulse process is z of t equal to dxt over dt. We can see in this graph. The probability mass is, there's not really probability mass for that because this is the impulse process, and the mean of it is e of z of t, which is equal to lambda, and autocorrelation is r of t1 t2 equal to lambda square minus lambda of the impulse of T1 minus T2, and the autocovariance is C of T1 T2 equal to lambda times the impulse of T1 minus T2. The fourth one is semi-random telegraph signal, which is P of n T1 T2 equal to k equal to e to the negative lambda times t over times lambda t to the k over k. X of t equal to 1 when k is even. from 0 to t, x of t equal to -1 while k is odd in interval 0 to t. And the probability masses is which is inverse of both one. For which is inverse, the only difference is here e to the negative lambda t. And here I got a mistake here. It's supposed to be -1. So for p of xt equal to -1, this is e to the lambda t. Here is e to the negative lambda t. And the mean is e of xt equal to e to the -2 times lambda times t. And the autocorrelation is r of t1, t2 equal to e to the -2 times absolute volume of t1 minus t2. And the autocovariance is c of t1, t2 equal to e to the -2 of t times the absolute volume of t1 minus t2 minus e to the -2 lambda times t1 plus t2. Oh, here. t1 plus t2. So the fifth one is random telegraph signal yt equal to axt, and the p of a equal to 1 equal to p of a equal to -1, which is equal to 1/2. And the probability masses is p of yt equal to 1 equal to, and also is same to the p of yt equal to -1, which is also equal to which is also equal to 0.5. And the mean of it is e of yt equal to 0, and the autocorrelation is rt1, t2 equal to e to the negative lambda times the absolute value of t1 minus t2. The autocovariance is c of t1, t2 equal to e to the -2 lambda times the absolute value of t1 minus t2. And for the random walk is x of nt equal to ks equal to n minus k times s, which is equal to 2ks minus ks. So the probability masses is x of p of xt equal to xnt equal to rs, which is equal to n of n plus r over 2 times 1/2 to the n. And the mean is e of x equal to 0. And the autocorrelation is e of xt1 times xt2, which is minimum of n and m times s squared, which is the same as autocovariance. For the question 2, we also require to collect the definition of properties of each name of following. So and then explain the understanding about these properties. For the y-sense stationary process, it means a constant. Its mean is a constant, and the autocorrelation is a function of time difference. For the independent increase process means x of t1 minus xt2 and xt3 minus xt4 on non-overlapping interval are independent. And for Markov process for xt, if the past has no influence on the future when the present is unknown. For the normal process for the xt, for a normal process for xt is if the random variable xt1, xt2 to the xtn are jointly normal for any n and any t. And for any t. And a strict sense stationary process is the statistics is not affected by a shift on the time axis. For the main ergodic process is in this equation, the limit of t equal to infinity, 1 over t times the integral from t to the negative of xt dt, which is equal to e of xt in the mean square sense. And the last one is for martingales. It's for xt that for all xt that e of t over x of s equal to x1 equal to x1, where s is smaller or equal than t.